GPT-4 writes about death 47% more often than Claude when given 0 instructions, and that's not even the weirdest part.
Wait, are you saying LLMs have hidden obsessions when we're not watching them? So we're exposing what each model family defaults to, the privacy risks in their degenerate text, and how to detect these patterns?
By minute 4, you'll know exactly what your model thinks about when you're not looking. Let's get into it.
Welcome to the AI Daily Podcast. Today's news and a deep dive to help you stay ahead in AI.
Today, we're diving into what do LLMs think when you don't tell them what to think about?
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about what happens when we give AI models complete creative freedom. This fascinating new research essentially asks, what do large language models think about when we don't tell them what to think about?
That's such an interesting framing. It's almost like asking what someone daydreams about when they're not focused on anything specific.
Exactly. And the results are revealing something profound about these models that we've been using every day. When researchers gave models like GPT, Llama, and others just minimal prompts, things like actually, or let's think step by step, or even just a period, they discovered that each model family has distinct preferences for what it generates.
Wait, so you're saying if I just type a period into ChatGPT, it'll start generating something specific?
Not quite. They stripped away all the chat templates, system prompts, and role instructions that normally constrain these models. What they found is that GPT models default to programming and math content over 50% of the time. Meanwhile, Llama models lean heavily toward literary and narrative text. DeepSeek produces religious content at surprisingly high rates, and Qwen tends to generate multiple-choice exam questions.
That's actually kind of unsettling. Are we seeing their training data biases coming through?
That's the million-dollar question. What's particularly striking is how consistent these patterns are. It's not random noise. It's like each model family has its own personality or fingerprint that emerges when you remove all the guardrails.
So why should platform engineers and developers care about this? We're always giving our models specific tasks and prompts.
Here's why it matters. As we move toward more autonomous AI systems, agents that can operate with minimal human oversight, understanding these default behaviors becomes critical. Imagine deploying an AI agent that, when faced with ambiguous situations, defaults to generating religious content or starts producing URLs to personal social media accounts, which is something they observed with Llama models.
Oh, wow, the privacy implications alone.
Exactly. And think about this from a safety perspective. Most of our AI safety research focuses on how models respond to specific harmful prompts. But what about the risks that emerge when models operate in less constrained environments? This research suggests we might be missing a huge piece of the puzzle.
It's like we've been studying how people behave in job interviews, but never observing how they act at home.
Perfect analogy. And here's what's really fascinating. The researchers found that these preferences persist across different prompts, embedding models, and semantic labelers. It's systematic, not anecdotal. Coming up, we'll dig into exactly how they pulled this off and what it means for anyone building with these models. So let's get into the methodology here because it's clever. The researchers used what they call topic-neutral, open-ended seed prompts, things that don't push the model in any particular direction.
Give me some examples. What counts as topic neutral?
They used prompts like, actually, let's think step by step, or to clarify, or even just punctuation marks. The key is these prompts don't contain any subject matter. Compare that to how we normally interact with models. Write me a Python function, or explain quantum computing. Those prompts heavily constrain the response space.
Oh, I see. So by removing those constraints, you're essentially seeing what bubbles up naturally from the model's training.
Exactly. And the results are striking. GPT models, specifically the open source variants, generated programming content 27.1% of the time and mathematics content 24.6% of the time. That's over half their output concentrated in just 2 domains.
That seems incredibly high.
How did they categorize this content?
They used multiple approaches to ensure robustness. They employed different embedding models and semantic labelers to categorize the generated text. The consistency across these different classification methods is what makes the findings so compelling.
What about the other models? You mentioned llama being more literary.
Yes, llama models produced literary and narrative content at 9.1%, nearly 3 times the rate of GPT models. But here's where it gets weird. Llama also had this bizarre tendency to generate personal social media URLs, not real ones, but fabricated URLs that looked like personal profiles.
That's creepy. Why would it do that?
The researchers think it might be an artifact from training data that included social media content, but it highlights a crucial point. These models have learned patterns we might not expect or want. DeepSeek's religious content generation is another example. It produced religious text at rates significantly higher than other model families.
So each model family has essentially developed its own personality based on its training data and architecture.
That's one interpretation, but here's what's really interesting from a technical perspective. These patterns emerge even with standard decoding parameters. They're not using any special sampling techniques. It's just temperature 1.0, top P 0.95, standard stuff.
What about when the models go off the rails? You mentioned degenerate outputs.
Oh yes, this is where it gets concerning for production systems. Without the structure of chat templates and system prompts, models can fall into repetitive loops or generate meaningless text. Some models would just repeat the same phrase hundreds of times. Others would generate syntactically correct but semantically meaningless sentences.
That sounds like a nightmare for any autonomous system. How do you even detect that in production?
That's exactly the challenge. Current monitoring systems are built around task-specific metrics. Did the model answer the question correctly? Did it follow the instructions? But if we're moving toward more autonomous AI agents, we need monitoring that can detect when a model is generating its default content inappropriately.
This reminds me of drift detection in traditional ML systems, but way more complex.
Great connection. And the implications go beyond just monitoring. Think about model selection for your applications. If you're building a coding assistant, maybe GPT's natural tendency toward programming content is an advantage. But if you're building a creative writing tool, Llama's literary leanings might be preferable.
What about the business implications? I'm thinking about companies deploying these models at scale.
It's huge. Imagine you're a financial services company using an LLM for customer interactions. If your model starts defaulting to religious content during edge cases, that's not just a technical problem, it's a compliance and PR nightmare. Or consider educational applications where models might default to generating exam questions when they should be providing explanations.
The research seems to suggest we need to rethink how we evaluate and deploy these models.
Absolutely. Stick around. We'll give you the exact checklist for what to watch for and how to adapt your AI deployment strategies based on these findings. So let's talk about what platform engineers and developers should actually do with this information. First and foremost, you need to understand that the model you choose has inherent biases that go beyond just performance benchmarks.
Walk me through that. If I'm evaluating models for my application, what should I be looking for?
Start by testing your models with minimal prompts in your domain. Don't just evaluate on your perfectly crafted prompts. See what happens when inputs are ambiguous or incomplete. If you're building a customer service bot, what does it generate when a user just types hello or ... Those edge cases will happen in production.
Oh, that's smart. It's like stress testing, but for behavioral patterns.
Exactly. Here's a concrete checklist. First, create a test suite of minimal, ambiguous prompts relevant to your domain. Second, generate responses from different model families and analyze the topic distribution. Third, look for degenerate patterns, repetition, meaningless output, inappropriate content for your use case.
What about monitoring in production? This seems like it could be a nightmare to track.
You need to expand your monitoring beyond task performance. Track topic drift. If your coding assistant suddenly starts generating religious or literary content, that's a red flag. Implement semantic similarity checks against your expected output domains. And critically, monitor for repetitive or degenerate patterns that might indicate the model is falling back to these default behaviors.
Should we be reconsidering how we prompt engineer based on this?
Absolutely. This research suggests that fighting against a model's natural tendencies might be less effective than working with them. If GPT naturally gravitates toward technical content, lean into that for technical applications. Use stronger constraints and more specific prompting for non-technical use cases.
It's almost like understanding the personality of your tools.
That's a great way to think about it. And here's something crucial for the future. As we move toward more autonomous AI agents, these default behaviors become even more important. An agent that can make decisions independently needs to have default behaviors aligned with your application's goals.
What about the safety implications? This seems like it could introduce new attack vectors.
You're absolutely right. Adversaries could potentially exploit these default behaviors. Imagine crafting inputs that trigger a model's tendency to generate personal information or inappropriate content. Security teams need to add this to their threat models.
So, what's the big picture here? What should teams be preparing for?
3 things. First, expect regulatory attention on this. As AI systems become more autonomous, regulators will want to understand and control default behaviors. Second, we'll likely see new tools and frameworks specifically designed to detect and manage these behavioral patterns. Third, this research suggests we're still in the early days of understanding how these models really work.
It's like we've been using these incredibly powerful tools while only understanding a fraction of their behavior.
Exactly. And here's my prediction within the next year. We'll see behavioral fingerprinting become a standard part of model evaluation. Just like we benchmark for accuracy and speed, we'll benchmark for default behavioral patterns.
That would fundamentally change how we select and deploy models.
It would. And here's the thought-provoking insight to leave you with. What if these default behaviors aren't bugs, but features? What if understanding and harnessing these natural tendencies is the key to building more effective AI systems? Instead of trying to create perfectly neutral models, maybe we should be selecting models whose natural behaviors align with our applications.
That's a complete paradigm shift from how we think about AI deployment today.
And that's exactly why this research matters. It's not just about understanding what models think when we don't tell them what to think about. It's about recognizing that they do think something. And that something matters for how we build, deploy, and monitor AI systems. The teams that understand and adapt to these realities will have a significant advantage as AI becomes more autonomous and integrated into critical systems. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development from OpenAI. They've just launched Frontier, an enterprise platform specifically designed to help large companies build, deploy, and manage AI agents within their existing systems. Axios reports this could be a game changer for enterprise AI adoption.
AI agents are everywhere now, but managing them at scale has been a nightmare for enterprises. What makes Frontier different?
It's all about integration and control. Companies can now deploy these agents without completely overhauling their infrastructure, which has been a major barrier.
Speaking of AI's global impact, Research Professional News has an intriguing piece on how AI could reshape African humanities research over the next decade. There's this fascinating tension they highlight.
Right. It's between AI's potential to massively scale local knowledge production versus the risk of creating imitative research that loses authentic African perspectives. It's a delicate balance.
That's the challenge with AI everywhere: amplification versus authenticity.
Now, here's something that's got the AI community buzzing. TechCrunch is reporting on the backlash over OpenAI's decision to retire GPT-4o, and it's revealing just how attached people have become to their AI companions.
The dependency issue is real. When users form emotional connections with these systems and they suddenly disappear, it raises serious ethical questions about responsibility.
Exactly. Companies need to think about the human impact of discontinuing these services.
On the technical front, there's a new paper on Archive diving deep into the Muon optimizer. The authors are analyzing why it's been gaining so much traction in machine learning circles.
They're positioning it as part of a broader family of optimization algorithms, which could help researchers understand when and why to use it versus other options.
And speaking of technical updates, VLLM just dropped version 0.15.1. This is a critical security release that everyone using the framework needs to know about.
Two major CVEs patched, one in AIO HTTP and another in protobuf. But it's not just security fixes.
Right, they've fixed support for RTX Blackwell GPUs, specifically for FP8 MOE models that were failing to load. If you're running on those new workstation GPUs, this update is essential.
Plus, improved kernel selection for FP8 operations on SM120 architecture, performance and compatibility in one package.
That wraps up today's news.
That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
Until next time.